Two-way tables. In chapters 4 and 5, we considered relationships between two quantitative variables. In this chapter, we use two-way tables to describe relationships between two categorical variables. Some variables, such as sex, race, and occupation, are categorical by nature. Other categorical variables are created by grouping values of a quantitative variable into classes. To explore relationships between two categorical variables, we use the counts or percentages of individuals that fall into various categories. As with quantitative variables, we must be alert to the influence of lurking variables and be careful not to assume that the patterns we observe would continue to hold for additional data or in a broader setting. Example 6.1, Who earns academic degrees? In 2017, the National Center for Education Statistics projected the number of academic degrees to be awarded in 2020 to 2021 for men and women. Table 6.1 shows their projections. This is a two-way table because it describes two categorical variables. One is the sex of an individual. The other is the academic degree earned. Sex is the row variable because each variable in the row describes the sex of an individual. Academic degree conferred is the column variable because each column describes a degree. Because academic degree conferred has a natural order from associate to professional doctorate, the columns are in this order. The entries in the table are the counts of individuals in thousands by each sex by academic degree class. The entries in the right margin are the total of the row entries, the entries in the bottom margin are the total of the column entries, and the entry at the bottom right is the total of all students projected to receive an academic degree in 2020 to 2021. Two-way table. A table of counts used to organize data about two categorical variables. Values of each row variable run across the table, and values of each column variable run vertically down the table. Entries in the table are the counts of how often each combination of the corresponding row and column variables occur. Two-way tables are often used to summarize large amounts of information by grouping observations into categories. When you complete this chapter, you will be able to compute and interpret marginal distributions in two-way tables, compute and interpret conditional distributions in two-way tables, recognize and explain Simpson's paradox. 6.1 Marginal distributions. How can we best grasp the information contained in Table 6.1? First, look at the distribution of each variable separately. The distribution of a categorical variable says how often each outcome occurred. The total column at the right of the table contains the totals for the rows. These row totals give the distribution of sex in the entire group of 3,905,000 students. 2,283,000 are women, and 1,622,000 are men. If the row and column totals are missing, the first thing to do in studying a two-way table is to calculate them. The distributions of sex alone and degree conferred alone are called marginal distributions because they appear at the right and bottom margins of the two-way table. Marginal distributions. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among all individuals described by the table. Percentages are often more informative than counts. We can display the marginal distribution of sex in percentages by dividing each row total by the table total and converting to a percentage. Example 6.2, calculating a marginal distribution. The percentage of these students in Table 6.1 who are women is women total divided by table total equals 2,283 divided by 3,905 equals 0.585 equals 58.5%. Repeat such a calculation to obtain the marginal distribution of men, or subtract 58.5% from 100%. Here is the complete distribution. When the response was women, the percentage is 58.5%. When the response was men, the percentage is 41.5%. More women are projected to receive degrees than men. The total is 100% because everyone belongs to one of the four sex and education classes. Each marginal distribution from a two-way table is a distribution for a single categorical variable. As we saw in Chapter 1, we can use a bar graph or a pie chart to display such a distribution. Figure 6.1 is a bar graph of the distribution of sex among students in the sample. In working with two-way tables, you must calculate lots of percentages. Here's a tip to help you decide what fraction gives the percentage you want. Ask, what group represents the total of which I want a percentage? The count for that group is the denominator of the fraction that leads to the percentage. In example 6.2, we want a percentage of students, so the count of students, the table total, is the denominator. Figure 6.1, bar graph of the distribution of sex of adults who participated in the survey. This is one of the marginal distributions for table 6.1. So it's a bar graph, and on the x-axis is sex, and there's women and men. On the y-axis is percentage of students from 0 to 100%, and you can see the woman bar is around 60%, and the man bar is around 40% of students. So you can see more women are getting degrees than men. And the percentages of the two bars will add up to 100% because everyone is in a category. Apply your knowledge. 6.1, video gaming and grades. The popularity of computer, video, online, and virtual reality games has raised concerns that they might negatively affect youth. The data in this exercise are based on a recent survey of 14 to 18-year-olds in Connecticut high schools. Here are the grade distributions of boys who have and have not played video games. A. How many people does this table describe? How many of these have played video games? To find this, you add the interior numbers of the table and you get 1,808. How many people played video games? You add the sum of the row played games, which is the first row values together, so you get 1,379. B. Give the marginal distribution of the grades. What percentage of the boys represented in the table received a grade of C or lower? Okay, so to do the marginal distribution of grades for each of the grade categories, you take the column total or the row total, which I calculated and added in to the two-way table, and you divide it by the total number of observations, which I calculated in A as 1,808. So then you end up with like this mini new table, which is the titles of the columns, and there's two columns are grade and percentage. And then you get the three percentages for the three grade categories. What percentage of boys received a grade of C or lower? So then you add the percentage from the C category and the percentage from the D's and F's category to get 47.95%.